After learning basics about how to write a VHDL code, let us look at a tutorial for using quartus 2 as a tool to design entry using VHDL and simulation. Quartus 2 is a tool which we will open for design entry. First thing what we need to do is create a project for the design that we want to make. When you click on create a new project, there is a new project wizard which gets opened, which will prompt you to get some basics about the project like project name, entity name, the path where you want to store the project, the target device that we will be using in this project, and the simulation tool which we will be using, and so on. So first thing what we need to do is choose appropriate folder and project name. Please note that the project name that we enter in this place will be just copied in this place as the top level entity name for the project. If we use the same entity name in the code that we are writing, it is alright, but if we do have some different entity name, then we have to enter that name over here. Next, what it prompts is the device that we are going to use. So choice of a device to implement. We have to know the board which we are using and choose appropriate device family and the detailed device. Then we have to choose the simulation tools. Here we are going to use Model Sim Altera as the tool and VHDL as the format of the design entry. We all know that writing a VHDL code means specifying entity which will also specify the interface with the external world, basically defining the input-output ports, and the architecture which describes the design's behavior and its functionality. Of course, the architecture has no existence without an entity, and hence any VHDL code is going to be a pair of entity and architecture. So we have to write a VHDL code for a given design problem. I'm here giving you an example of architecture which is written for a half adder and a full adder using a component of half adders. Now I gave the VHDL code of half adder and full adder because once you write and enter VHDL code in the project, then we have to compile that and we can see what is known as RTL or register transfer logic corresponding to the design that we have used. So a half adder RTL will look like this, made up of XOR gate and AND gate, whereas the full adder using two half adders will look like this, where there are two half adders and a OR gate used in the full adder. Next step is to test the circuit or the design that we've made. So to test the design that we have made, we have to write another VHDL code which is known as a test bench. So if you look at how to write a test bench, what we have to do is create an empty entity because this test bench does not get interfaced with the external world. It doesn't have any inputs or outputs, but it does have an architecture which is supposed to have following components. It should have a component which is to be tested. So we should declare the component which is to be tested. Typically it is known as design under test or the design which we have created. It should also have signals corresponding to all ports of the design under test. We should instantiate the DUT or design in the architecture of the test bench, and we should use a process to apply inputs through the signals to the DUT. So this is a structure of a typical test bench architecture, which will always have component and signal declarations and which will always have DUT instantiation and process to apply inputs to DUT with appropriate time parameters. Once the test bench is made and compiled, then we need to link this test bench to the design that we have included in the project. So choose assignment option in the top menu, and out of that choose option which is known as EDA tool setting. Once you click on that, you have to choose simulation as the option. The window which pops up will look like this, out of which we have to tick the compile test bench and click on test benches. Once you click on test benches, a window which pops up asks for details about the test bench file name, the test bench entity name, and the design entity name. Now make sure that the names which we enter in this and this place correspond to test bench file name, correspond to test bench entity name, and correspond to design entity name. Once we do that, we have to choose the appropriate test bench file and add to the menu. Once you do this, the linking of test bench and design is being done. Then we have to choose tools option, out of which run EDA simulation tool choice and EDA RTL simulation choice. Then the model sim simulator will open and it will create a waveform which is inclusive of the signals that we have written in the test bench. It will also show the values of values of those signals at different time parameters in a waveform manner, in which we can cross check what are the inputs and their corresponding outputs. Now the correctness of the outputs here we are checking manually in the waveform. This is a waveform for a 4-bit adder. Earlier was the waveform for a full adder. So this is the way we can use Quartus and Model Sim Altera for design entry using VHDL and simulation by writing a test bench for the given design.